In this problem, we're asked to complete a table where we find the cation and anion, which will include the symbol and the charge, for each of these following compounds. Now, it's very important to remember that all ionic compounds are neutral. And this is because the anion loses electrons and the cation gains electrons, but the number of electrons lost and the number of electrons gained must be exactly the same. So the take-home message is all ionic compounds are neutral. So in order to find the charge, we have to use some rules. Some of the atoms have well-known charges, others do not. So if we look here, the first example is manganese to sulfide. And what we want to do is find the charge on manganese, which I inadvertently just said. Anyway, how did I figure that out? Well, what I want to first do is look at sulfide. So manganese is a transition metal. Some transition metals only have one known charge, but that could change tomorrow. So, meaning that somebody could find that transition metal with another charge in some compound. So let's use the nonmetal to figure out the charge on the metal. So sulfur is in group 6A, so when it forms ionic compounds, which it has here because it's a metal and a nonmetal, it's going to have a -2 charge because it's in group 6A. So if I know the charge on sulfide, I can find the charge on manganese. So what you want to do is manganese S. So manganese -2 equals 0. Said another way, the charge on manganese minus the charge on sulfur, or plus the negative charge on sulfur, equals 0, the overall charge on the species. Add 2 to both sides. Manganese equals +2. So we have Mn2+ as the cation, and S2- as the anion. Cobalt, chloride, we can do the same thing. Cobalt is again a transition metal, so we don't know its charge, but we do know chloride. Chloride is in 7A, so it's -1. So in this case, we have CoCl2. So what you want to do in this case is Co plus 2 times -1, 2 chlorides times -1 charge each equals 0. Co -2 equals 0. Add 2 to both sides. Co equals +2. So we have CO2+ and Cl-. Here we have vanadium F2. So V is vanadium, again a transition metal, but fluorine is a halogen again, so it's in group 7A. So I'm going to do this one over here. If we do VF2, what we have is V plus 2 times -1 equals 0, the overall charge. So what you get is V, -2 equals 0, because 2 times -1 is -2, equals 0. Add 2 to both sides, and you get V equals +2. So we get V2+ F- as the cation and the anion. Finally, we have NiO, which I'm going to do over here. So NiO. Nickel is also a transition metal. Oxygen is in 6A just like sulfur, so it forms -2 charges. Another way, oxygen wants to gain 2 electrons to be like neon. Exact same thing. Ni plus -2 equals 0, or simply Ni -2 equals 0. Add 2 to both sides. Ni equals +2. So Ni is 2+, and O is 2-. Alright? Notice you cannot simply reverse the subscripts. It doesn't work in the case of MnS or NiO, because if they're both 2, you cross them out. So you can't simply reverse the subscripts. You do need to do this algebra in order to find the charges on each of the species. Just by coincidence, these are all 2+. Not every metal is 2+.